everyone, welcome to the Ansible Full Course by Simplilearn. Managing servers, application and configuration manually is very painful. One typo, one misstep and your system can go haywire. That's why automation is the game changer and Ansible is at the heart of it. Ansible lets you automate everything from deployment to orchestration and without writing complex scripts. Now imagine spinning up servers, configuring apps, and managing environments with a single command. That's not magic, that's Ansible. In this course, we will take you through hands-on automation, writing playbooks, managing inventories, and streamlining IT workflows like a pro. And the career upside, IT automation, DevOps, cloud engineering professionals skilled in Ansible are in high demand across every tech industry. And by the end of this course, you won't just know Ansible. You will be the automation ninja every team wants on board. So ready to automate, optimize, and supercharge your IT career? Hit that like, smash subscribe, and let's dive into Ansible. So before we begin, here's a quick information. If you are interested to grow your career in cloud computing and DevOps, then the professional certification is a great way to start. The professional certificate program in cloud computing and DevOps by Simplilearn is the right choice for you. This is an 8-month live interactive online program from ENICT Academy Online and Microsoft. This program will help you master key in-demand skills like Microsoft Azure, Amazon AWS, Dockers, containers, and much more, alongside leveraging the power of generative AI and LLMs. This adds great credibility to your profile by earning certificates from ENICT Academy and Microsoft. You will also get career support including resume help, mock interviews, and job assistance. And in just 8 months, you will master application migration, containerization, continuous delivery, along with 47 plus skills. So whether you're switching careers or upskilling, this course gives you the latest cloud computing and DevOps with AI knowledge and practical experience to stay ahead. So what are you waiting for? Hurry up and enroll now and you can find the course link below. Let's get started.
So guys, as you can see all over here, I am on the official Ansible documentation. But the question is, why have I opened this documentation? So guys, this is an official documentation by the team of Ansible, and I would always want you to refer this documentation while learning Ansible. Guys, Ansible is a versatile automation tool tailored for IT professionals, which enables tasks such as application deployment, workstation, server updates, cloud provisioning, configuration management, and intra-service orchestration. Notably, it stands out for the agentless nature, requiring no additional security infrastructure for deployment, which simplifies its use and management. Now, what are the benefits of using Ansible? If I talk about the benefits of using Ansible, Ansible offers several benefits. The first one is agentless architecture. Ansible doesn't require agents to be installed on managed nodes, thus reducing complexity and potential security vulnerabilities. This agentless approach simplifies deployment and management. Moving ahead, we will also discuss about what are managed nodes and control nodes. Then there is a cross-platform support. Ansible can manage diverse environments including Linux, Unix, and Windows subsystem, as well as network devices and cloud platforms, providing unified solution for automation across different infrastructures. Third one is scalability. Whether managing a handful of servers or large-scale infrastructure, Ansible scales effectively. It can handle thousands of nodes with ease, allowing organizations to automate tasks across their entire environment. Fourth one is integration. Ansible integrates seamlessly with existing tools and technologies, including version control systems like Git, monitoring solutions, and continuous integration delivery pipelines, enhancing the overall automation workflow. Now you'll be wondering, how does Ansible works? So guys, in Ansible, there are two main types of computers. The first one is control node and second one is managed nodes. The control node is where Ansible is installed and operated. It's essential to have one control node, though having a backup control node is also possible. On the other hand, managed nodes are the devices or systems controlled and managed by the control node. Ansible operates by establishing connection to these nodes, whether they are servers, clients, or other entities you are configuring. It then sends small programs known as Ansible modules to these nodes. These modules are executed over SSH, which stands for Secured Server Shell, and are also removed after the completion. The key requirement for this process is that Ansible control node has a login access to the managed nodes, while SSH keys are commonly used for access and other authentication methods. Now we are going to install Ansible on the Docker. So guys, to install Ansible within a Docker, the first thing that you need is a VS Code. So guys, to install a text editor, you can go directly to the VS Code. So guys, you can see this is the official website of the VS Code, and from here you can download your favorite text editor. It runs very smooth. And later on, what you have to do guys, you have to go to the Docker's official website. So you can see this is the first link of the official Docker, and from here you can download Docker desktop on your system. So guys, if you don't know how to install Docker, you will see a video in the link. Just click on that and you will be very easily navigated to installing Docker on your Windows system. Now, after you have installed VS Code and Docker, the next step comes up installing Ansible within Docker container. So it's certain thing like you are installing a package over a virtual machine, and our virtual machine is acting as a container which is on a Docker platform. So guys, as you can see all over here, so here's a file I have created. So this is the folder Ansible, and inside this I have created the Docker file. So your first step would be to create a Docker file. Now, after this, you have to ensure that a Docker is installed on your host machine. Okay. Then after creating a Docker file, you have to specify the instructions for building your Ansible container. So here's a basic example. Like here you can see from Ubuntu latest. So I have added install dependencies, app.get update, app.get install, app.y software properties common, add repository, yes, update pp Ansible, and app.get install by. So as you can see guys, I have written this script all over here. Okay. Now let us try to understand this script. So you can see all over here the first thing, that is from Ubuntu latest. What does it mean? This sets the base image for the Docker file. It indicates that the Docker image being built will be based on the latest version of Ubuntu operating system available on the Docker Hub. Next thing is run apt-get update. So guys, this line runs the apt-get update command inside the Docker container to update the package list from the repositories. And the and symbol which you are seeing is a line continuation character in the Docker file, which allows the command to span up to multiple lines. Third command, as you can see all over here, is written apt-get install y software. So basically what it's doing, this line install the software properties common package using apt-get. This package provides an abstraction of used apt repositories. It often requires for adding PPAs, which means that personal package archives to the system. In the next line, you can see I have written apt add repository, yes. You have to update the PPA Ansible and Ansible and. So this line basically what it does, it adds the Ansible PPA, means Ansible personal package archive to the system. PPAs are kind of additional software repositories for Ubuntu. This particular PPA provides the latest stable release of Ansible. And you can see there is a yes flag which automatically answers yes to the prompts and update and ensures that the package lists are updated after adding to the repository. The apt-get install by Ansible, this line installs Ansible using apt-get. Ansible is a configuration management and automation tool. So guys, this line installs Ansible using apt-get. Now after all, Ansible is a configuration management and automation tool. So after building the Docker image using the Docker file, now we have to run this container using the docker run command. And it follows with the it flag. Okay, so let me show you. So guys, as you can see, I have already been navigated to my directory of Ansible. So you can see docker build t is the argument, okay, and a container. A container is a name. So let us say a name as demo container. Now we are going to build our image first. So I'm typing this command, right click on this, and let me show you what is happening. So as you can see, it started building our Ansible container all over here inside the Docker. Now, we have installed the Ansible all over here. Now the next step is to run our Docker container, which has installed Ansible image. So just type this command, docker run and it Ansible container bin bash. Let me explain you this command. So guys, after building the Docker image using this Docker file, you can run a container from it using the docker run command. The it flag allocates the sudo tty and keeps the stdin open even if not attached, allowing you to interact with the container shell. /bin/bash. This specifies that you want to start a bash shell session inside the container. Now, when you're inside the container, you can verify that Ansible is installed by running Ansible version. Now, we'll also do that, but before that, let's run our container. So, you can see, now we are inside a bash container or bash shell, and I want to check whether our Ansible is installed or not. So, I'm going to type Ansible version. So, you can see that our latest version is 3.1.2, and you can see the Python version, it's also saying 3.12.3. So guys, congratulations, we have successfully installed our Ansible in the Docker. So guys, this was just a basic overview of Ansible and what it has the capabilities for. You can do a lot of things with Ansible and automate a lot of processes like configuration management. You can create your playbooks and just run it. So in that way, it automates your process and it makes your workflow kind of easier.
So let's begin. Why should you use Ansible? Let's consider a scenario of an organization where Sam is a system administrator. Sam is responsible for the company's infrastructure. A company's infrastructure basically consists of all its systems. This could include your web servers, your database servers, the various repositories, and so on. So as a system administrator, Sam needs to ensure that all the systems are running the updated versions of the software. Now, when you consider a handful of systems, this seems like a pretty simple task. Sam can simply go from system to system and perform the configurations required. But that is not the case with an organization, is it? An organization has a very large infrastructure. It could have hundreds and thousands of systems. So here is where Sam's work gets really difficult. Not only does it get tougher, Sam has to move from system to system, performing the same task over and over again. This makes Sam bored. Not just that, repeating the same task leaves no space for innovation. And without any ideas or innovation, how does the system grow? And the worst of it all is manual labor is prone to errors. So what does Sam do? Well, here is where Ansible comes in use. With Ansible, Sam can write simple codes that are deployed onto all the systems and configure them to the correct states. So now that we know why we should use Ansible, let's look at what exactly is Ansible. Ansible is an IT engine that automates the following tasks. So first we have orchestration. Orchestration basically means bringing together of multiple applications and ensuring an order in which these are executed. So for example, if you consider a web page that you require to host, this web page stores all its values that it takes from the user into a database. So the first thing you must do is ensure that the system has a database manager, and only then do you host your web page. So this kind of an order is very crucial to ensure that things work right. Next, Ansible automates configuration management. So configuration management simply means that all the systems are maintained at a consistent desired state. Other tools that automate configuration management include Puppet and Chef. And finally, Ansible automates deployment. Deployment simply means the deploying of application onto your servers of different environments. So if you have to deploy an application on 10 systems with different environments, you don't have to manually do this anymore because Ansible automates it for you. In fact, Ansible can also ensure that these applications or the code are deployed at a certain time or after regular intervals. Now that we know what exactly Ansible is, let's look at Ansible's architecture. Ansible has two main components. You have the local machine and you have your node or the client machine. So the local machine is where the system administrator sits. He or she installs Ansible here. And on the other end, you have your node or the client systems. So in case of Ansible, there's no supporting software installed here. These are just the systems that require to be configured and they are completely controlled by the local machine. At your local machine, you also have a module. A module is a collection of your configuration files. And in case of Ansible, these configuration files are called playbooks. Playbooks are written in YAML. YAML stands for YAML ain't a markup language. and it is honestly the easiest language to understand and learn since it's so close to English. We also have the inventory. The inventory is a file where you have all your nodes that require configuration mentioned. And based on the kind of configuration they require, they're also grouped together. So later in the demo, we'll have a look at how the playbook and the inventory is written, and that will probably make it clearer. So of course, a local machine needs to communicate with the client. And how is this done? This is done through SSH. SSH is your secure shell, which basically provides a protected communication in an unprotected environment. Okay, so we saw the various components of Ansible. Now, how does Ansible exactly work? You have your local machine on one end. This is where you install Ansible. If you have gone through any previous material on Ansible, you would have come across the term agentless often being associated with this tool. So this is what agentless means. You're installing Ansible only on your local machine and there's no supporting software or plugin being installed on your clients. This means that you have no agent on the other end. The local machine has complete control and hence the term agentless. Another term that you would come across with Ansible is push configuration. So since the local machine has complete control here, it pushes the playbooks onto the nodes and thus it's called a push configuration tool. Now the playbooks and the inventory are written at the local machine and the local machine connects with the nodes through the SSH client. This step here is optional but it's always recommended to do so. It's where the facts are collected. So facts are basically the current state of the node. Now all this is collected from the node and sent to the local machine. So when the playbook is executed, the task mentioned in the playbook is compared against the current status of the node and only the changes that are required to be made further are made. And once the playbooks are executed, your nodes are configured to the desired states. So as I mentioned before, Ansible is currently the most trending tool in the market under the configuration management umbrella. So let's have a look at the various benefits of Ansible which gives it this position. Well, Ansible is agentless, it's efficient, it's flexible, simple, idempotent, and provides automated reporting. How does it do all this? Let's have a look at that. Agentless, as I already mentioned before, you require no supporting software or plugin installed on your node or the client system. So the master has complete control. And automatically this means that Ansible is more efficient because now we have more space in our client and node systems for other resources and we can get Ansible up and running real quick. Ansible is also flexible. So an infrastructure is prone to change very often and Ansible takes no amount of time to adjust to these changes. Ansible cannot get any simpler with your playbooks written in a language such as YAML, which is as close to English as you can possibly get. Idempotent basically means that if you have a playbook which needs to be run n number of systems, it would have the same effect on all of these systems without any side effect. And finally, we have automated reporting. So in case of Ansible, your playbook has a number of tasks and all these tasks are named. So whenever you run or execute your playbook, it gives a report on which tasks ran successfully, which failed, which clients were not reachable, and so on. All this information is very crucial when you're dealing with a very large infrastructure. And finally, we reach the most exciting part of our tutorial, the hands-on. Before we move on to the actual hands-on, let me just brief you through what exactly we'll be doing. So I'll be hosting two virtual boxes, both CentOS 7 operating systems. One would be my local machine and other my node or the client machine. So on my local machine, first I'll install Ansible. We'll then write the inventory and the playbook and then simply deploy this playbook. On the client machine, there's just one thing that we need to do is that we need to check if the configurations that we mentioned in our playbook are made right. So we'll now begin our demo. This is my Oracle VirtualBox. Here I have my master system, which is the local machine, and this is the client machine. So let's have a look at these two machines. This is my client machine. The terminal is open right now. So the client machine terminal has a black background with white text. And the master machine terminal has a white background with black text, just so you can differentiate between the two. So we'll start at the master machine. The first thing to do is we need to install our Ansible. So yum install Ansible-y is the command to do so. So this might take some time. Yeah, so Ansible's installed. The next step, we go to our host file. So our host file here is basically the inventory. It's where you'll specify all your nodes. In our case, we just have one node. That's the path to your host file. As you'll see, everything here is commented. So just type in the group for your client nodes. So I'm going to name it Ansible Clients. And here we need to type the IP address of our client machine. So my client machine's IP address is 192.168.2.127. So before you come to this, it's advised that you check the IP address on your client machine. The simple command for that is ifconfig. Now once you type the IP address, put a space, and here we need to mention the username and the password for our client. So I'll be logging in as the root user. So this is the password. And then the user. Which is root in my case. That's it. Now you can save this file. Just clear the screen. Next, we move on to our playbook. We need to write the playbook. So the extension for our playbook is YML, which stands for YAML. And as you can see here, I have already written my playbook, but I'll just explain to you how this is done. So a YAML file always begins with 3 dashes. This indicates the start of your YAML file. Now the first thing is you need to give a name to the entire playbook. So I have named it sample book. Host is basically where this would be executed. So as we saw earlier in our inventory, I mentioned client's group name as Ansible Clients. So we use the same name here. The remote user is the user you'll be using at your client. So in my case, that's root. And become true is basically to indicate that you need to set your privileges at root. So that's called a privilege escalation. Now a playbook consists of tasks. So we have here 3 tasks. The first task, I've named it to install HTTPD. So what we are doing here is we are installing our HTTPD package, which is basically the Apache server. And we are installing the most latest version of it. Hence the state value is latest. The next task is running HTTPD. So for the service, the name is HTTPD because that's the service we need to start running and the state is started. Our next task is creating content. So this is the part where we are creating our web page. So copy because this is the file that will be created at the client. The content will be welcome and the destination of the file will be var www.html index.html. As you know, this is like a default path that we use to store all our HTML files. Now, as you can see here, there's quite a lot of indentation. And when it comes to YAML, although it's very simple to write and very easy to read, the indentation is very crucial. So the first dash here represents the highest stage, that is the name of the playbook, and all the dashes under tasks are slightly shifted towards the right. So if you have 2 dashes at the same location, they basically mean that they are siblings. So the priority would be the same. So to ensure that all your tasks are coming under the tasks label, make sure they are not directly under name. So yeah, that's pretty much it. So when you write your YAML file, the language is pretty simple, very readable. Indentations absolutely necessary. Make sure all your spaces are correctly placed. We can now save this file. Next thing we need to check if the syntax of our YAML file is absolutely right because that's very crucial. So the command to check the syntax of the YAML file is Ansible playbook, the name of your playbook, syntax check. So we have no syntax errors, which is why the only output you receive is sample.yml, which is the name of your playbook. So our playbook is ready to be executed. The command to execute the playbook is Ansible playbook and the name of your playbook. So our playbook's executed, as you can see here, gathering facts. That's where all the facts of the node, that's the present state of the node, is collected and sent to the local machine. So it's basically to check that if the configuration changes that we are about to make is already made. So it's not made. We do not have the HTTPD package installed on our node. So this is the first change that's made. Also, if it's not installed, of course, it's not running. That's the second change that's made. So it's put into the running state. And a final task, which is create content, is under the OK state. This means that the content's already present in the client machine. So I made it this way so that you can at least see the different states that's present. So over here we have OK4, so 4 things are all fine. The facts are gathered, 2 things are changed, and 1 is already present. 2 changes are made. 0 clients are unreachable and 0 tasks have failed. So this is the documentation that I was referring to previously that Ansible provides automatically and is very useful, as you can see. So our next step, we need to just check on our client machine if all the changes that we desired are made. So let's move to our client. So this is my client machine. So to check this, since we are installing the HTTPD package and hosting a web page, the best way to do it is open your browser and type in localhost. So there you go. Your Apache server is installed and your web page is hosted. So that was very simple, wasn't it? If you have any doubts about the procedure or any other part of the tutorial, please post your doubts in the comment section below and we'll get back to you as soon as we see them.
So the first month is about choosing a programming language. So when you're diving into the world of DevOps, picking up a programming language is a game changer. It helps you automate tasks, integrate systems, and troubleshoot those tricky issues that pop up. So now the language you pick up can depend on the project you're working on. But the key skills you learn are going to be applied everywhere. So for beginners, I highly recommend starting with languages like Python or Go. Why? Because both are super easy to learn, have clean syntax, and are widely used across the IT industry. So now let's break down what all you have to learn under each of these languages. So in Python, you'll start with Introduction to Python. So you'll start with the basics like understanding how Python works, its syntax, and how to write clean, readable code. Then comes data types and variables. So here you will learn the fundamental building blocks like strings, integers, and lists. Then comes conditionals and loops. So get comfortable with if-else statements and loops. So these control the flow of your code. Then comes functions and modules. So organize your code into reusable functions and modules for clean, maintainable projects. Now next on the list is OOPS or object-oriented programming. So here you'll dive into classes and objects. This is key for structuring your code effectively. And finally, you can go through some advanced concepts to explore things like exception handling, file input-output, regex, collections, and more to level up your Python game. Now in Golang, again, you can start with Introduction to Golang. Like Python, Go's syntax is simple, but it's powerful for handling large-scale systems. After the introduction, you can move on to variables and constants. So here you can learn how to declare variables and constants essential for clean code. Then comes arrays and slices. Now these are Go's way of handling collections of data. After this comes concurrency and Go routines. So Go's real strength lies in handling multiple tasks at once. So you can get comfortable with Go routines for parallel processing. And finally, you can learn interfaces and methods. So Go is all about simplicity, but interfaces and methods let you write more flexible and reusable code. Now once you have completed these modules, you'll be going to the second month where you'll be dealing with operating systems. So basically, operating systems are like the backbone of any computing environment. So they connect the hardware with the software. So as a DevOps engineer, you need a solid understanding of operating system to effectively manage applications, optimize infrastructure, and streamline deployment pipelines. So let's go through some of the key operating system concepts you'll need to know. First one is OS Basics. So this is the foundation, understanding what an operating system does and how it works. Then comes processes and threads. So you can get familiar with the process life cycle and how threads are managed within processes. Then next comes CPU scheduling. So learn how tasks are assigned to CPU resources and how time is allocated for different processes. Process synchronization. This ensures that processes don't clash with each other while running. Now next comes deadlock. So sometimes processes get stuck in a loop. So understanding how to identify and resolve these situations is crucial. And then there is memory management. So how does the operating system manage memory? So learning memory allocation strategies will make your systems run smoother. And finally, you'll learn about disk management and scheduling. So this is all about efficiently handling disk usage and optimizing read-write operations, which are key to keeping things running faster. And also in the second month, you'll be dealing with virtualization. So DevOps engineers should also be familiar with different types of virtualization to manage resources efficiently. So some of the virtualizations that you can get familiar with are application virtualization, network virtualization, desktop virtualization, storage virtualization, server virtualization, and data virtualization. Now let's move on to the third month. So if you want to be a top-tier DevOps engineer, mastering the command line interface or CLI is a must. So it gives you advanced control over systems and access to powerful features that go beyond the limitations of a graphical user interface or GUI. So being proficient in the CLI means you can manage, you can troubleshoot, and configure systems more efficiently. So whether you're working locally or remotely. This is especially crucial when it comes to infrastructure management and automating tasks across different environments and operating systems. So let's look at some key CLI skills to master. So number one is scripting. This is for automating repetitive tasks and creating custom scripts to make your work more efficient. Then next you can learn about editors. So learn CLI-based editors like Vim or Nano for editing files directly from the terminal. Then you can learn about networking tools. So get comfortable with tools like Ping, Netstat, and curl to troubleshoot network issues and manage network configurations. Next is process monitoring. So here you have to learn how to use tools like PS, Top, or HTOP to monitor processes and system performance in real time. After process monitoring comes performance monitoring, where tools like SAR and IOStat help you keep track of system performance and resource usage. And finally comes text manipulation. So you can master text processing tools like AWK, SED, and grep to handle and analyze large datasets directly from the terminal. So by becoming proficient in the CLI, you'll be able to solve problems faster, gain deeper insights into system behavior, and effectively manage infrastructure with confidence. Now moving on to the fourth month, if you're diving into DevOps, version control and hosting are non-negotiable. So they play a crucial role in collaboration, code management, and version tracking, especially if you're looking to implement GitOps or streamline your DevOps lifecycle. So when it comes to version control, Git is the go-to tool. It's the most widely used distributed version control system. So Git lets you create repositories to store your code, work with branches to make and test changes without affecting the main code base, make commits to save your progress and merge changes with others' works, and track every change made, which makes collaboration easy. And next comes hosting platforms. So once your code is neatly tracked with Git, it's time to host it. So hosting platforms let you make your code public or share it with your organization. So popular options are number one, GitHub. So this is the most popular platform for open source projects with tons of collaboration features. And then you have Bitbucket. So this is a great choice, especially for teams already using Atlassian tools like Jira. And finally, there is GitLab. It is a feature-rich platform with integrated CI/CD pipelines for better DevOps workflow. So with Git and these hosting platforms, you'll have all the tools needed to manage your code base, collaborate smoothly with your team, and keep track of every change. So now let's move on to the fifth month. So in the fifth month, you're supposed to learn about cloud providers. So in your DevOps journey, understanding cloud computing is a game changer. So ultimately, all the applications you work on will be hosted somewhere, right? And that somewhere could be either on a cloud or on-premise. So there are a few big players in the cloud space that you'll want to get familiar with. Number one is, of course, AWS, Amazon Web Services. So AWS is one of the most popular cloud platforms, offering a ton of services. So whether it's EC2 for virtual machines, S3 for storage, or Lambda for serverless computing, AWS has a service for almost every need. And next you have Azure. So Azure is Microsoft's cloud platform and offers a wide range of services similar to AWS. However, the standout for DevOps professionals is Azure DevOps. It's a suite of integrated tools that covers everything from CI/CD pipelines to version control and project management. And then comes GCP, or Google Cloud Platform. So Google Cloud offers many of the same services as AWS and Azure, but with a unique touch. So whether you're working with Kubernetes or looking for storage options, GCP brings Google's power and reliability to the table. So now that we have completed the plan till the 5th month, you can take a moment to answer the next quiz in the description box. So I hope you have answered the quiz. So in the 6th month, you'll be dealing with containerization with Docker. So if you're serious about DevOps, Docker is a tool you can't afford to skip. So before Docker came, deploying applications involved packaging the app, downloading all necessary dependencies into the server, and manually configuring everything. So the scaling was a nightmare. But with Docker, packaging and deploying the app is a breeze, and it makes scaling super easy too. So here's what you have to concentrate while learning Docker. Number 1 is running containers. So learn how to run containers, essentially lightweight standalone applications on any system. Next, inspect active containers. So get comfortable with checking which containers are running, their status, and any issues that might pop up. And then you have Docker networking. So understand how containers communicate with each other and the outside world, which is key to a well-architected system. Then you'll want to persist data with Docker volumes. So by default, containers are ephemeral, meaning the data disappears when they stop. So learn how to use volumes to persist data beyond the life of a container. Next, you can learn about Dockerizing apps with Docker files. So master writing Docker files, simple text files that define how to build a Docker image for your app. Next, run multiple containers with Docker Compose. So learn how to manage multi-container apps using Docker Compose, which simplifies complex setups. And finally, there is Docker repositories. So learn how to work with Docker Hub or private repositories to store and share Docker images with others. So with Docker, deploying apps becomes faster, easier, and more scalable, making it an essential tool for any DevOps engineer. Also in the 6th month, you'll be dealing with container orchestration. So we have covered containers, right, and how they make scaling a breeze. But what if you need to manage lots of containers at once? So that's where container orchestration tools come in. So these tools let you automate the management of containers, like creating multiple replicas and scaling them as needed. So the two main players in this space are Kubernetes and Docker Swarm. So in the 7th month, you'll be moving on to networking and security protocols. So networking and security are the backbone of any DevOps process, especially since most of your work will be on servers and in production environments. So understanding networking concepts helps you manage and troubleshoot infrastructure. Deploy microservices, handle containerized application, automate network tasks. So here are some of the key concepts you have to learn in network and security. The first one is FTP, SFTP. So these are protocols for transferring files securely over the network. Then there is HTTP and HTTPS. So the foundation for web communication, and you should know the difference and when to use each of these. Then comes SSL, TLS. So these are the encryption protocols that secure the web traffic, keeping data safe. Then next you have DNS. So the system that helps convert domain names into IP addresses, basically the address book of the internet. Then you'll be dealing with SSH, which is a secure protocol used for remote server management and communication. Then you will move on to other protocols such as TCP/IP and UDP, which are also crucial. So with this knowledge, you'll have the tools to keep your network secure and your infrastructure running smoothly. Now in the 8th month, you must concentrate on understanding serverless computing. So this is a cloud computing model where you don't have to worry about managing or provisioning servers. So instead, cloud providers dynamically allocate resources as needed, allowing you to focus purely on writing and deploying your code. So as a DevOps engineer, here are the key tools and platforms you should dive into. First one is Cloudflare. So Cloudflare offers a suite of services including CDN and security, but also enables serverless computing for edge functions, speeding up your applications globally. Next is AWS Lambda. So AWS Lambda is Amazon's serverless platform, allowing you to run code without provisioning or managing servers. So you can get it to trigger in response to events, making it highly scalable and efficient. And then comes some Azure Functions. So Azure Functions from Microsoft offers similar serverless capabilities, enabling you to run small pieces of code in the cloud. And finally, there is Vercel. So Vercel is a cloud platform that focuses on serverless deployment for modern web apps, particularly for front-end applications. So by mastering these serverless computing, you'll be able to streamline your app development process, reduce costs, and let cloud providers handle the heavy lifting for you. Also in the 8th month, you'll be dealing with infrastructure provisioning. So as a DevOps engineer, you'll need to manage and set up infrastructure. But using traditional methods like ClickOps can be time consuming and hard to scale. So luckily things have gotten a lot easier. So infrastructure provisioning is all about automating the setup of your infrastructure. So some of the key tools in this area are Terraform, Pulumi, and AWS CDK. And then you have got configuration management. So basically configuration management is all about keeping track of and controlling the configuration of your infrastructure, software, and systems. So imagine in any organization, you will often need to manage multiple servers. And imagine doing this manually for hundreds or even thousands of servers. It's not only time consuming, but also prone to errors, right? So that's where configuration management tools comes in. So here are some essential tools to master in configuration management. Number one is Ansible. So Ansible is a simple and powerful automation that lets you configure servers, deploy apps, and manage tasks. So next there is Chef. This is another automation tool. So it's great for larger environments where scalability and flexibility is needed. And then you have Puppet. So Puppet allows you to manage infrastructure with a declarative language. So it's widely used for managing large-scale infrastructure and automating repetitive tasks across systems. Now moving on to the 9th month, you'll be dealing with infrastructure monitoring. So infrastructure monitoring is all about keeping an eye on the health and performance of your infrastructure and tracking its availability, checking for issues, and predicting future problems before they occur. So you collect data from system logs, metrics, and other streams and use that data to spot any potential issues. So here are some top tools you should learn for infrastructure monitoring. So first one is Grafana. So Grafana is a powerful open source tool that lets you visualize metrics and logs from multiple sources. Then you have Datadog. So again, Datadog is a cloud-based platform that offers comprehensive monitoring of infrastructure, performance, and logs. And then you have Prometheus. So Prometheus is an open source monitoring tool designed for reliability and scalability. So it's perfect for tracking time series data, and you can easily integrate with Grafana to give rich visualizations. Now finally, you have to learn about application monitoring. So application monitoring is crucial, especially when deploying updates or bug fixes. So a new change could unexpectedly take the app down. But with continuous monitoring, you can track, measure, and analyze the app's performance in real time to prevent issues from escalating. So here are some key tools for application monitoring. So number one is Datadog itself. So just like in infrastructure monitoring, Datadog is a great tool for application monitoring also, providing deep insights into your app's performance logs and other metrics. So it's perfect for real-time visibility. And then you have New Relic, you have Jaeger, and then there is Open Telemetry and App Dynamics. Now, in your final month of DevOps learning, focus on hands-on projects that put your knowledge into practice. Work on building pipelines, managing infrastructure, and monitoring systems. So this is the time to apply what you have learned and showcase your skills through real-world experience.
Hello, this is Matthew with Simplilearn, and today we're going to go through a real tough battle. We're going to decide which is better for your operations environment. Is it Chef, Puppet, Ansible, or SaltStack? All four are going to go head to head. So let's go through the scenario of why you'd want to use these tools. So let's meet Tim. He's our system administrator, and Tim is a happy camper putting and working on all of the systems in his network. But what happens if a system fails? If there's a fire, a server goes down? Well, Tim knows exactly what to do. He can fix that fire really easily. The problems become really difficult for Tim, however, if multiple servers start failing, particularly when you have large and expanding networks. So this is why Tim really needs to have a configuration management tool, and we need to now decide what would be the best tool for him, because configuration management tools can help make Tim look like a superstar. All he has to do is configure the right codes that allows him to push out the instructions on how to set up each of the servers quickly, effectively, and at scale. All right, let's go through the tools and see which ones we can use. The tools that we're going to go through are Chef, Puppet, Ansible, and SaltStack. And we have videos on most of these software and services that you can go and view to get an overview or a deep dive in how those products work. So let's go and get to know our contestants. So our first contestant is Chef. And Chef is a tool that allows you to configure very large environments. It allows you to scale very effectively across your entire ecosystem and infrastructure. Chef is by default an open source code. And one of the things that you find as a consistent metaphor for the tools that we recommend on Simplilearn is to use open source code. The code itself is actually written in language of Ruby and Erlang. And it's really designed for heterogeneous infrastructures that are looking for a mature solution. The way that Chef works is that you write recipes that are compiled into cookbooks, and those cookbooks are the definition of how you would set up a node. And a node is a selection of servers that you have configured in a specific way. So for instance, you may have Apache Linux servers running, or you may have a MySQL server running, or you may have a Python server running. And Chef is able to communicate back and forth between the nodes to understand what nodes are being impacted and need to have instructions sent out to them to correct that impact. You can also send instructions from the server to the nodes to make a significant update or a minor update. So there's great communication going back and forth. If we look at the pros and cons, the pros for Chef is that there is a significant following for Chef, and that has resulted in a very large collection of recipes that allow you to be able to quickly stand up environments. There's no need for you to have to learn complex recipes. The first thing you should do is go out and find the recipes that are available. It integrates with Git really well and provides for really good, strong version control. Some of the cons, though, are really around the learning speed it takes to go from beginner user with Chef to being an expert. There is a considerable amount of learning that has to take place, and it's compounded by having to learn Ruby as the programming language. And the main server itself doesn't really have a whole lot of control. It's really dependent on the communication throughout the whole network. All right, let's look at our second contender, Puppet. And Puppet is actually in many ways very similar to Chef. There are some differences, but again, Puppet is designed to be able to support very large heterogeneous organization. It is also built with Ruby and uses DSL for writing manifests. So there are some strong similarities here to Chef. As with a Chef, there is a master-slave infrastructure with Puppet, and you have a master server that has the manifests that you put together in a single catalog, and those catalogs are then pushed out to the clients over an SSL connection. Some of the pros with Puppet is that, as with Chef, there is a really strong community around Puppet, and there's just a great amount of information and support that you can get right out of the gate. It is a very well developed reporting mechanism that makes it easier for you as an administrator to be able to understand your infrastructure. One of the cons is that you have to really be good at learning Ruby again, as with Chef. You know, the more advanced tasks really need to have those Ruby skills. And as with Chef, the server also doesn't have much control. So let's look at our third contender here, Ansible. And so Ansible is slightly different. It is, the way that Ansible works is that it actually just pushes out the instructions to the server environment. There isn't a client server or master slave environment where Ansible would be communicating backwards and forwards with its infrastructure. It is merely going to push that instructions out. The good news is that the instructions are written in YAML, and YAML stands for YAML Ain't Markup Language. YAML is actually pretty easy to learn. If you know XML, and XML is pretty easy, if you know XML, you're going to get YAML really well. Ansible does work very well on environments where the focus is getting servers up and running really fast. It's very, very responsive and can allow you to move quickly to get your infrastructure up very fast. And we're talking seconds and minutes here, really, really quick. So again, the way that Ansible works is that you put together a playbook and an inventory, or you have a playbook. So the way that Ansible works is that you have a playbook, and the playbook, it then goes against the inventory of servers and will push out the instructions for that playbook to those servers. So some of the pros that we have for Ansible: we don't need to have an agent installed on the remote nodes and servers. It makes it easier for the configuration. YAML is really easy to learn. You can get up to speed and get very proficient with YAML quickly. The actual performance, once you actually have your infrastructure up and running, is less than other tools that we have on our list. Now, I do have to add a proviso. This is a relative less. It's still very fast. It's going to be a lot faster than individuals manually standing up servers, but it's just not as fast as some of the other tools that we have on this list. And YAML itself as a language, while it's easy to learn, it's not as powerful as Ruby. Ruby will allow you to do things that at an advanced level that you can't do easily with YAML. So let's look at our final contender here, SaltStack. So SaltStack is a CLI-based tool. It means that you will have to get your command line tools out or your terminal window out so you can actually manage the entire environment via SaltStack. The instructions themselves are based on Python, but you can actually write them in YAML or DSL, which is really convenient. And as a product, it's really designed for environments that want to scale quickly and be very resilient. The way that SaltStack works is that you have a master environment that pushes out the instructions to what they call grains, which is your network. And so let's step through some of the pros and cons that we have here with SaltStack. So SaltStack is very easy to use once it's up and running. It has a really good reporting mechanism that makes your job as an operator in your DevOps environment much, much easier. The actual setup, though, is a little bit tougher than some of the other tools, and it's getting easier with the newer releases, but it's just a little bit tougher. And related to that is that SaltStack is fairly late in the game when it comes to actually having a graphical user interface for being able to create and manage your environment. Other tools such as Ansible have actually had a UI environment for quite some time. All right, so we've gone through all 4 tools. Let's see how they all stack up next to each other. So let the race begin. Let's start with the first stage, architecture. So the architecture for most of our environments is a server-client environment. So for Chef, Puppet, and SaltStack. So very similar architecture there. The one exception is Ansible, which is a client-only solution. So you're pushing out the instructions from a server and pushing them out into your network, and there isn't a client environment. There isn't a two-way communication back to that main client for what's actually happening in your network. So let's talk about the next stage, ease of setup. So if we look at the 4 tools, there is one tool that really stands out for ease of setup, and that is Ansible. It is going to be the easiest tool for you to set up. And if you're new to having these types of tools in your environment, you may want to start with Ansible just to try out and see how easy it is to create automated configuration before looking at other tools. Now, and so with that said, Chef, Puppet, and SaltStack aren't that hard to set up either. And you'll find there's actually some great instructions on how to do that setup in the online community. Let's talk about the languages that you can use in your configuration. So we have 2 different types of language, with both Chef and Ansible being procedural in that they actually specify how you're actually supposed to do the task in your instructions. With Puppet and SaltStack, it's decorative, where you specify only what to do in the instructions. Let's talk about scalability. Which tools scale the most effectively? And as you can imagine, all of these tools are designed for scalability. That is the driver for these kind of tools. You want them to be able to scale to massive organizations. What do the management tools look like for our 4 contenders? So again, we have a 2-way split. With Ansible and SaltStack, the management tools are really easy to use. You're going to love using them. They're just fantastic to use. With Puppet and Chef, the management tools are much harder to learn, and they do require that you learn some either the Puppet DSL or the Ruby DSL to be able to be a true master in that environment. But what does interoperability look like? Again, as you'd imagine, with the similar to scalability, interoperability with these products is very high in all 4 cases. Now, let's talk about cloud availability. This is increasingly becoming more important for organizations as they move rapidly onto cloud services. Well, both Ansible and SaltStack have a big fail here. Neither of them are available in the most popular cloud environments. And Puppet and Chef are actually available in both Amazon and Azure. We've actually just haven't had a chance to update our Chef link here, but Chef is now available on Azure as well as Amazon. So what does communication look like with all of our 4 tools? So the communication is slightly different with them. Chef has its own knife tool, whereas Puppet uses SSL, so Secure Sockets Layer, and Ansible and SaltStack use Secure Socket Hashing, SSH, as their communication tool. Bottom line, all 4 tools are very secure in their communication. So who wins? Well, here's the reality. All 4 tools are very good, and it's really dependent on your capabilities and the type of environment that you're looking to manage that will determine which of these 4 tools you should use. The tools themselves are open source, so go out and experiment with them. There's a lot of videos. Our team has done a ton of videos on these tools, and so feel free to find out other tools that we have and covered so you can learn very quickly how to use them. But consider the requirements that you have and consider the capabilities of your team. If you have Ruby developers or you have someone on your team that knows Ruby, your ability to choose a broader set of tools becomes much more interesting. If, however, you're new to coding, then you may want to consider YAML-based tools. Again, the final answer is going to be up to you, and we'll be really interested on what your decision is. Please post in the comments below which tool you have decided to go with and what are the challenges that you're coming up with, because we'll help answer those challenges for you.
We'll take you through how you can install Ansible and how you can use the tool to automate your processes. First, we have Anjali to tell us how to install Ansible on your system.
A very warm welcome to all our viewers. I'm Anjali from Simplilearn, and today I'll be showing you how you can install the configuration management tool Ansible. So let's have a brief about why one would use Ansible and what exactly is Ansible. So if you consider the case of an organization, it has a very large infrastructure, which means it has more than probably hundreds of systems. And giving one or even a small team of people the responsibility to configure all these systems makes their work really tough, repetitive, and as you know, manual work is always prone to errors. So Ansible is a tool which can automate the configuration of all these systems. With Ansible, a small team of system administrators can write simple codes in YAML, and these codes are deployed onto the hundreds and thousands of servers, which configures them to the desired states. So Ansible automates configuration management, that is configuring your systems. It automates orchestration, which means it brings together a number of applications and decides an order in which these are executed, and it also automates deployment of the applications. Now that we know what Ansible does, let's move on to the installation of Ansible. So here is my Oracle VM VirtualBox Manager. I'll be using 2 systems. There's the node system, which is basically my client system, and there's the server system or the master system. So let's begin at our server system. So this is my master system, guys. So the first thing we do is we download our Ansible tool. So one thing we must remember with Ansible is that unlike Chef or Puppet, Ansible is a push type of configuration management tool. So what this means is that the entire control here lies with your master or your server system. This is where you write your configuration files, and these are also responsible for pushing these configuration files onto your node or client system as and when required. Great, so our Ansible tool is installed. Now we need to open an Ansible host file, and there we'll specify the details of our node or client machine. So this is our Ansible host file. As you can see here, the entire file is commented, but there's a certain syntax that you'd observe. For example, here we have a group name, web servers, under which we have the IP addresses or certain host name. So this is about how we'll be adding the details for our client system. First, we need to give a group name. Under this group, basically, we add all the clients which require a certain type of configuration. Since we are using just one node, we'll give only the details for that particular node. First, we need to add the IP address of our client machine. So let's just go back to our client machine. And this here is the IP address, 192.168.2.11. Once you have typed in your IP address, give a space, and then we'll specify the user for our client machine. So all communications between the server or the master system and the client or the node system takes place through SSH. SSH basically provides a secure channel for the transfer of information. Follow this up with your password. In my case, it's the root's password. And that's it, we are done. So now we save this file and go back to our terminal. So now that our host file is written, the next thing we do is we write our playbook. So playbook is the technical term used for all the configuration files that we write in Ansible. Now playbooks are written in YAML. YAML's extremely simple to both write and understand. It's in fact very close to English. So now we'll write our playbook. The playbook or any code in YAML first starts with 3 dashes. This indicates the beginning of your file. Next thing, we need to give a name to our playbook. So name, and I'm going to name my playbook sample book. We next need to specify our host systems, which is basically the systems at which the configuration file or the playbook in our case will be executed. So we'll be executing this at the client machines mentioned under the group Ansible servers. So we had just one client machine under it. We'll still mention the group name. We next need to specify the username with which we'll be logging into our client machine, which is root in my case. And become true specifies that you need to become the root to execute this playbook. So becoming the root's called a privilege escalation. Next, we need to specify our tasks. So these are basically the actions that the playbook will be performing. So you would have noticed everything so far is aligned, that is name, host, remote user, become and task, because these are at one level. Now whatever comes under task will be shifted slightly towards the right. Although YAML is extremely simple to understand and read both, it's a little tricky while writing because you need to be very careful about the indentations and the spacing. So my first task is install HTTPD, which is basically an Apache server. So now my command's yum, and this will be installing the HTTPD package. And the latest state of it will be installed. So that's our first task. Now our second task would be running our Apache service. So name, run HTTPD, and the action, which is service, will be performed on HTTPD, hence the name HTTPD, and state must be started. Now we come to our third task. So here we'll create a very simple web page that will be hosted. So create content is the name of our task. And the content that we are creating here will basically be copied to our node system at a particular file location that we'll provide. Our content will be congrats. And then we'll provide the destination at which this file will be copied. So this is the default location for all our HTML files. And that's it. We are done writing our playbook. Just save this and go back to your terminal. Before we execute the playbook or push the playbook onto our node system, let's check the syntax of our playbook. So the command for doing so is, and if everything's fine with your playbook, the output would be just your playbook name. So our syntax is perfectly fine. Now we can push on the playbook to our node or the client machine. And that's the syntax for doing so. Now, as your playbook is being sent over to the client machine, you can see that first the facts are gathered. That is, the current state of your client machine is first fetched to check what all is to be changed and what is already present. So the first thing is installing HTTPD. So our system already had HTTPD. So it says OK, because this does not need to be changed. Our next task was running HTTPD. Now, although our system had the Apache service, it was not running. So that is one thing that was changed. The next was there was no content available. So the content was also added. So 2 tasks were changed and 4 things were okay. Now everything seems fine. And before you move any forward, it is very important that you check this one line of documentation provided by Ansible. You have all kind of information available here regarding which all tasks were executed, if your client machine was reachable or unreachable, and so on. So now that everything's fine here, we can move on to our node system and we'll just go to our browser. So if our playbook has been executed here, what should happen is that the HTTPD service must be in the running state and the web page that we created should be hosted. So let's just type localhost And great, everything's working fine. So our web page is displayed here. So we come to an end for our installation and configuration video for the configuration management tool Ansible. If you have any doubts, please post them in the comment section below and we'll definitely get back to you as soon as possible.
Thanks, Anjali. Now we have Matthew and Anjali to take us through how to work with Ansible.
Ansible today as one of the key tools that you would have within your DevOps environment. So the things that we're going to go through today is we're going to cover why you would want to use a product like Ansible, what Ansible really is and how it's of value to you in your organization, the differences between Ansible and other products that are similar to it on the market and what makes Ansible a compelling product. And then we're going to dig into the architecture for Ansible. We're going to look at how you would create a playbook, how you'd manage your inventory of your server environments, and then what is the actual workings of Ansible. As a little extra, we're going to also throw in Ansible Tower, one of the secret source solutions that you can use for improving the speed and performance of how you create your Ansible environments. And finally, we're going to go through a use case by looking at Hootsuite, a social media management company, and how they use Ansible to really improve the efficiency within their organizations. So let's jump into this. So the big question is, why Ansible? So you have to think of Ansible as another tool that you have within your DevOps environment for helping manage the servers. And this definitely falls on the operations side of the DevOps equation. So if we look here, we have a picture of Sam, and like yourselves, Sam is a system administrator, and he is responsible for maintaining the infrastructure for all the different servers within his company. So some of the servers that he may have that he has to maintain could be web servers running Apache, they could be database servers running MySQL. And if you only have a few servers, then that's fairly easy to maintain. I mean, if you have 3 web servers and 2 database servers, and let's face it, wouldn't we all love just to have 1 or 2 servers to manage? It would be really easy to maintain. The trick, however, is as we start increasing the number of servers, and this is a reality of the environments that we live and operate in, it becomes increasingly difficult to create consistent setup of different infrastructures such as web servers and databases for the simple reason that we're all human. As if we had to update and maintain all of those servers by hand, there's a good chance that we would not set up each server identically. Now, this is where Ansible really comes to the rescue and helps you become an efficient operations team. Ansible, like other system solutions such as Chef and Puppet, uses code that you can write and describe the installation and setup of your servers. So you can actually repeat it and deploy those servers consistently into multiple areas. So now you don't have to have one person redoing and refollowing setup procedures. You just write one script and then each script can be executed and have a consistent environment. So we've gone through why you'd want to use Ansible. Let's step through what Ansible really is. So, this is all great, but, how do we actually use these tools in our environment? So Ansible is a tool that really allows you to create and control 3 key areas that you would have within your operations environment. First of all, there's IT automation. So you can actually write instructions that automate the IT setup that you would typically do manually in the past. The second is the configuration and having consistent configuration. Imagine setting up hundreds of Apache servers and being able to guarantee with precision that each of those Apache servers is set up identically. And then finally, you want to be able to automate the deployment so that as you scale up your server environment, you can just push out instructions that can deploy automatically different servers. The bottom line is you want to be able to speed up and make your operations team more efficient. So let's talk a little bit about pull configuration and how it works with Ansible. So there are 2 different ways of being able to set up different environments for server farms. One is to have a key server that has all the instructions on, and then on each of the servers that connect to that main master server, you would have a piece of software known as a client installed on each of those servers that would communicate to the main master server and then would periodically either update or change the configuration of the slave server. This is known as a pull configuration. An alternative is a push configuration, and the push configuration is slightly different. The main difference is, as with a pull configuration, you have a master server where you actually put up the instructions. But unlike the pull configuration where you have a client installed on each of the services, with a push configuration, you actually have no client installed on the remote servers. You simply are pushing out the configuration to those servers and forcing a restructure or a fresh, clean installation in that environment. So Ansible is one of those second environments where it's a push configuration server. And this contrasts with other popular products like Chef and Puppet, which have a master-slave architecture with a master server connecting with a client on a remote slave environment where you would then be pushing out the updates. With Ansible, you're pushing out the service and the structure of the server to remote hardware, and you are just putting it onto the hardware irrelevant of the structure that's out there. And there are some significant advantages that you have in that you're not having to have the extra overhead weight of a client installed on those remote servers, having to constantly communicate back to the master environment. So let's step through the architecture that you would have for an Ansible environment. So when you're setting up an Ansible environment, the first thing you want to do is have a local machine. And the local machine is where you're going to have all of your instruction and really the power of the control that you'd be pushing out to the remote server. So the local machine is where you're going to be starting and doing all of your work. Connected from the local machine are all the different nodes pushing out the different configurations that you would set up on the local machine. The configurations that you would write, and you would write those in code, are within a module. So you do this on your local machine for creating these modules, and each of these modules is actually consistent playbooks. The local machine also has a second job, and that job is to manage the inventory of the nodes that you have in your environment. The local machine is able to connect to each of the different nodes that you would have in your hardware network through SSH clients, so a secure client. Let's dig into some of the different elements within that architecture. And we're going to take a first look at playbooks that you would write and create for the Ansible environments. So the core of Ansible is the playbook. This is where you create the instructions that you write to define the architecture of your hardware. So the playbook is really just a set of instructions that configure the different nodes that you have, and each of those set of instructions is written in a language called YAML. And this is a standard language used for configuration server environments. Did you know that YAML actually stands for YAML Ain't Markup Language? That's just a little tidbit to hide behind your ear. So let's have a look at one of these playbooks it looks like. And here we have a sample YAML script that we've written. So you start off your YAML script with 3 dashes, and that indicates the start of a script. And then the script itself is actually consistent of 2 distinct plays. At the top we have play 1, and below that we have play 2. Within each of those plays we define which nodes are we targeting. So here we have a web server in the top play, and in the second play we have a database server that we're targeting. And then within each of those server environments, we have the specific tasks that we're looking to execute. So let's step through some of these tasks. We have an install Apache task, we have a start Apache task, and we have an install MySQL task. And when we do that, we're going to actually execute a specific set of instructions. And those instructions can include installing Apache and then setting the state of the Apache environment, or starting the Apache environment and setting up and running the MySQL environment. So this really isn't too complicated, and that's the really good thing about working with YAML, is it's really designed to make it easy for you as an operations lead to be able to configure the environments that you want to consistently create. So let's take a step back though. We have 2 hosts. We have web server and database server. Where do these names come from? Well, this takes us into our next stage and the second part of working with Ansible, which is the inventory management part of Ansible. So the inventory part of Ansible is where we maintain the structure of our network environment. So what we do here is part of the structure in creating different nodes is we've had to create 2 different nodes here. We have a web server node and a database server node. And under web server node, we actually have the names that we're actually pointing to specific machines within that environment. So now when we actually write our scripts, all we have to do is refer to either web server or database server, and the different servers will have the instructions from the YAML script executed on them. This makes it really easy for you to be able to just point to new services without having to write out complex instructions. So let's have a look at how Ansible actually works in real world. So the real world environment is that you would have the Ansible software installed on a local machine, and then it connects to different nodes within your network. On the local machine, you'll have your playbook, which is the set of instructions for how to set up the remote nodes. And then to identify how you're going to connect to those nodes, you'll have an inventory. We use secure SSH connections to each of the servers, so we are encrypting the communication to those servers. We're able to grab some basic facts on each server, so we understand how we can then push out the playbook to each server and configure that server remotely. The end goal is to have an environment that is consistent. So let's ask you a simple question. What are the major opportunities that Ansible has over Chef and Puppet? Really like to hear your answers in the comments below. Pop them in there and we'll get back to you, and really want to hear how you feel that Ansible is a stronger product, or maybe you think it's a weaker product as it compares to other similar products in the market. Here's the bonus. We're going to talk a little bit about Ansible Tower. So Ansible Tower is an extra product that Red Hat created that really kind of puts the cherry on the top of the ice cream, or is the icing on your cake. Ansible by itself is a command line tool. However, Ansible Tower is a framework that was designed to access Ansible. And through the Ansible Tower framework, we now have an easy to use GUI. This really makes it easy for non-developers to be able to create the environment that they want to be able to manage in their DevOps plan without having to constantly work with the command prompt window. So instead of opening up terminal window or a command window and writing out complex instructions only in text, you can now use drag and drop and mouse click actions to be able to create your appropriate playbooks, inventories, and pushes for your nodes. All right, so we've talked a lot about Ansible. Let's take a look at a specific company that's using Ansible today. And in this example, we're going to look at Hootsuite. Now, Hootsuite, if you've not already used their products, and they have a great product, Hootsuite is a social media management system. They are able to help with you managing your pushes of social media content across all of the popular social media platforms. They're able to provide the analytics, they're able to provide the tools that marketing and sales teams can use to be able to assess a sentiment analysis of the messages that are being pushed out. Really great tool and very popular. But part of their popularity drove a specific problem straight to Hootsuite. The challenge they had at Hootsuite is that they had to constantly go back and rebuild their server environment, and they couldn't do this continuously and be consistent. There was no standard documentation, and they had to rely on your memory to be able to do this consistently. Imagine how complex this could get as you're scaling up with a popular product that now has tens of thousands to hundreds of thousands of users. This is where Ansible came in and really helped the folks over at Hootsuite. Today, the DevOps team at Hootsuite write out playbooks that have specific instructions that define the architecture and structure of their hardware nodes and environments, and are able to do that as a standard product. Instead of it being a problem in scaling up their environment, they now are able to rebuild and create new servers in a matter of seconds. The bottom line is Ansible has been able to provide Hootsuite with IT automation, consistent configuration, and free up time from the operations team so that instead of managing servers, they're able to provide additional new value to the company.
A very warm welcome to all our viewers. I'm Anjali from Simplilearn, and today I'll be taking you through a tutorial on Ansible. So Ansible is currently the most trending and popular configuration management tool, and it's used mostly under the DevOps approach. So what will you be learning today? You'll learn why you should use Ansible, what exactly is Ansible, the Ansible architecture, how Ansible works, the various benefits of Ansible, and finally we'll have a demo on the installation of Apache or the HTTPD package on our client systems. We'll also be hosting a very simple web page, and during this demo, I'll also show you how you can write a very simple playbook in YAML and your inventory file. So let's begin. Why should you use Ansible? Let's consider a scenario of an organization where Sam is a system administrator. Sam is responsible for the company's infrastructure. A company's infrastructure basically consists of all its systems. This could include your web servers, your database servers, the various repositories, and so on. So as a system administrator, Sam needs to ensure that all the systems are running the updated versions of the software. Now, when you consider a handful of systems, this seems like a pretty simple task. Sam can simply go from system to system and perform the configurations required. But that is not the case with an organization, is it? An organization has a very large infrastructure. It could have hundreds and thousands of systems. So here is where Sam's work gets really difficult. Not only does it get tougher, Sam has to move from system to system, performing the same task over and over again. This makes Sam bored. Not just that, repeating the same task leaves no space for innovation. And without any ideas or innovation, how does the system grow? And the worst of it all is manual labor is prone to errors. So what does Sam do? Well, here is where Ansible comes in use. With Ansible, Sam can write simple codes that are deployed onto all the systems and configure them to the correct states. So now that we know why we should use Ansible, let's look at what exactly is Ansible. Ansible is an IT engine that automates the following tasks. So first we have orchestration. Orchestration basically means bringing together of multiple applications and ensuring an order in which these are executed. So for example, if you consider a web page that you require to host, this web page stores all its values that it takes from the user into a database. So the first thing you must do is ensure that the system has a database manager, and only then do you host your web page. So this kind of an order is very crucial to ensure that things work right. Next, Ansible automates configuration management. So configuration management simply means that all the systems are maintained at a consistent desired state. Other tools that automate configuration management include Puppet and Chef. And finally, Ansible automates deployment. Deployment simply means the deploying of application onto your servers of different environments. So if you have to deploy an application on 10 systems with different environments, you don't have to manually do this anymore because Ansible automates it for you. In fact, Ansible can also ensure that these applications or the code are deployed at a certain time or after regular intervals. Now that we know what exactly Ansible is, let's look at Ansible's architecture. Ansible has two main components. You have the local machine and you have your node or the client machine. So the local machine is where the system administrator sits. He or she installs Ansible here. And on the other end, you have your node or the client systems. So in case of Ansible, there's no supporting software installed here. These are just the systems that require to be configured, and they are completely controlled by the local machine. At your local machine, you also have a module. A module is a collection of your configuration files. And in case of Ansible, these configuration files are called playbooks. Playbooks are written in YAML. YAML stands for YAML ain't a markup language. And it is honestly the easiest language to understand and learn since it's so close to English. We also have the inventory. The inventory is a file where you have all your nodes that require configuration mentioned. And based on the kind of configuration they require, they're also grouped together. So later in the demo, we'll have a look at how the playbook and the inventory is written, and that will probably make it clearer. So of course, the local machine needs to communicate with the client. And how is this done? This is done through SSH. SSH is your secure shell, which basically provides a protected communication in an unprotected environment. Okay, so we saw the various components of Ansible. Now, how does Ansible exactly work? You have your local machine on one end, This is where you install Ansible. If you have gone through any previous material on Ansible, you would have come across the term agentless often being associated with this tool. So this is what agentless means. You're installing Ansible only on your local machine and there's no supporting software or plugin being installed on your clients. This means that you have no agent on the other end. The local machine has complete control and hence the term agentless. Another term that you would come across with Ansible is push configuration. So since the local machine has complete control here, it pushes the playbooks onto the nodes and thus it's called a push configuration tool. Now the playbooks and the inventory are written at the local machine and the local machine connects with the nodes through the SSH client. This step here is optional but it's always recommended to do so. It's where the facts are collected. So facts are basically the current state of the node. Now all this is collected from the node and sent to the local machine. So when the playbook is executed, the task mentioned in the playbook is compared against the current status of the node and only the changes that are required to be made further are made. And once the playbooks are executed, your nodes are configured to the desired states. So as I mentioned before, Ansible is currently the most trending tool in the market under the configuration management umbrella. So let's have a look at the various benefits of Ansible which gives it this position. Well, Ansible is agentless, it's efficient, it's flexible, simple, idempotent, and provides automated reporting. How does it do all this? Let's have a look at that. Agentless, as I already mentioned before, you require no supporting software or plugin installed on your node or the client system. So the master has complete control. And automatically this means that Ansible is more efficient because now we have more space in our client and node systems for other resources and we can get Ansible up and running real quick. Ansible is also flexible. So an infrastructure is prone to change very often and Ansible takes no amount of time to adjust to these changes. Ansible cannot get any simpler with your playbooks written in a language such as YAML, which is as close to English as you can possibly get. Idempotent basically means that if you have a playbook which needs to be run n number of systems, it would have the same effect on all of these systems without any side effect. And finally, we have automated reporting. So in case of Ansible, your playbook has a number of tasks and all these tasks are named. So whenever you run or execute your playbook, it gives a report on which tasks ran successfully, which failed, which clients were not reachable, and so on. All this information is very crucial when you're dealing with a very large infrastructure. And finally, we reach the most exciting part of our tutorial, the hands-on. Before we move on to the actual hands-on, let me just brief you through what exactly we'll be doing. So I'll be hosting 2 virtual boxes, both CentOS 7 operating systems. One would be my local machine and other my node or the client machine. So on my local machine, first I'll install Ansible. We'll then write the inventory and the playbook and then simply deploy this playbook. On the client machine, there's just one thing that we need to do is that we need to check if the configurations that we mentioned in our playbook are made right. So we'll now begin our demo. This is my Oracle VirtualBox. Here I have my master system, which is the local machine, and this is the client machine. So let's have a look at these 2 machines. This is my client machine. The terminal is open right now. So the client machine terminal has a black background with white text, and the master machine terminal has a white background with black text, just so you can differentiate between the two. So we'll start at the master machine. The first thing to do is we need to install our Ansible. So yum install Ansible-y is the command to do so. So this might take some time. Yeah, so Ansible's installed. The next step, we go to our host file. So our host file here is basically the inventory. It's where you'll specify all your nodes. In our case, we just have one node. That's the path to your host file. As you'll see, everything here is commented. So just type in the group for your client nodes. So I'm going to name it Ansible Clients. And here we need to type the IP address of our client machine. So my client machine's IP address is 192.168.2.127. So before you come to this, it's advised that you check the IP address on your client machine. The simple command for that is ifconfig. Now once you type the IP address, put a space, and here we need to mention the username and the password for our client. So I'll be logging in as the root user. So this is the password. And then the user. Which is root in my case. That's it. Now you can save this file. Just clear the screen. Next, we move on to our playbook. We need to write the playbook. So the extension for our playbook is YML, which stands for YAML. And as you can see here, I have already written my playbook, but I'll just explain to you how this is done. So a YAML file always begins with 3 dashes. This indicates the start of your YAML file. Now the first thing is you need to give a name to the entire playbook. So I have named it sample book. Host is basically where this would be executed. So as we saw earlier in our inventory, I mentioned client's group name as Ansible clients. So we use the same name here. The remote user is the user you'll be using at your client. So in my case, that's root. And become true is basically to indicate that you need to set your privileges at root. So that's called a privilege escalation. Now a playbook consists of tasks. So we have here 3 tasks. The first task, I've named it to install HTTPD. So what we are doing here is we are installing our HTTPD package, which is basically the Apache server. And we are installing the most latest version of it. Hence the state value is latest. The next task is running HTTPD. So for the service, the name is HTTPD because that's the service we need to start running and the state is started. Our next task is creating content. So this is the part where we are creating our web page. So copy because this is the file that will be created at the client. The content will be welcome and the destination of the file will be var www.html index.html. As you know, this is like a default path that we use to store all our HTML files. Now, as you can see here, there's quite a lot of indentation. And when it comes to YAML, although it's very simple to write and very easy to read, the indentation is very crucial. So the first dash here represents the highest stage, that is the name of the playbook, and all the dashes under tasks are slightly shifted towards the right. So if you have 2 dashes at the same location, they basically mean that they are siblings. So the priority would be the same. So to ensure that all your tasks are coming under the tasks label, make sure they are not directly under name. So yeah, that's pretty much it. So when you write your YAML file, the language is pretty simple, very readable. Indentations absolutely necessary. Make sure all your spaces are correctly placed. We can now save this file. Next thing we need to check if the syntax of our YAML file is absolutely right because that's very crucial. So the command to check the syntax of the YAML file is Ansible playbook, the name of your playbook, syntax check. So we have no syntax errors, which is why the only output you receive is sample.yml, which is the name of your playbook. So our playbook is ready to be executed. The command to execute the playbook is Ansible playbook and the name of your playbook. So our playbook's executed. As you can see here, gathering facts, that's where all the facts of the node, that's the present state of the node, is collected and sent to the local machine. So it's basically to check that if the configuration changes that we are about to make is already made. So it's not made. We do not have the HTTPD package installed on our node. So this is the first change that's made. Also, if it's not installed, of course, it's not running. That's the second change that's made. So it's put into the running state. And a final task, which is create content, is under the OK state. This means that the content's already present in the client machine. So I made it this way so that you can at least see the different states that's present. So over here we have OK4, so 4 things are all fine. The facts are gathered, 2 things are changed, and 1 is already present. 2 changes are made. 0 clients are unreachable and 0 tasks have failed. So this is the documentation that I was referring to previously that Ansible provides automatically and is very useful, as you can see. So our next step, we need to just check on our client machine if all the changes that we desired are made. So let's move to our client. So this is my client machine. So to check this, since we are installing the HTTPD package and hosting a web page, the best way to do it is open your browser and type in localhost. So there you go. Your Apache server is installed and your web page is hosted.
Hi guys, welcome to this video on the interview questions of configuration management tools, Chef, Ansible and Puppet. Chef is a configuration management tool written in Ruby and Erlang, which provides continuous deployment, increases system robustness, and provides cloud integration. Ansible is another open source software tool for provisioning configuration management and application deployment. And Puppet is a configuration management tool that can also be used as a deployment tool and implements infrastructure as a code. In this video, we have compiled the most important interview questions of configuration management tools, Chef, Ansible and Puppet that you might face in a DevOps interview. So without further ado, let's get started.
So let's just get into the first section, which is configuration management. So one of the questions that you'll get asked right away is, why do you have SSL certificates used for Chef? Really fundamentally, your immediate answer should be security. SSL provides for a very high level of private security and private and public key pairing. This really is essential to ensure that you have a secure environment throughout your entire network. The second part should be that if you're using SSL and you're using the private public key model within SSL, you're able to guarantee the systems on your network that the Chef, that you'll be able to validate that the nodes within your network that Chef is validating against actually are the real nodes themselves, not imposters. So you will also be asked some questions such as the following. Which of the following commands would you use to stop or disable the HTTP service when the system boots? And you'll typically get 4 responses, and there'll be hashtag systemctl disable httpd.service, or is it system disable http.service, system disable httpd, or the final option, which is systemctl disable httpd.service. Your answer should be the first one, which is hashtag systemctl disable http.service. So Chef comes with a series of tools that allow it to function effectively. And one of the tools that you're going to be asked about is, what is Test Kitchen? And Test Kitchen is essentially a command line tool that allows you to be able to test out your cookbook before you actually deploy it to a real node. So some of the commands that you would use are, for instance, if you want to create an instance of Test Kitchen, you would do kitchen create. If you want to destroy an instance after you created it, you do kitchen destroy. And if you want to be able to combine multiple instances, you would do kitchen converge. So a question you'll get is around Chef is, how does Chef Apply differ from Chef Client? So fundamentally, the difference between them is that Chef Apply will validate the recipe that you're working on, whereas Chef Client looks to apply and validate the entire cookbook that's run in your server environment. So one is focused on the recipe and the other is focused on the entire cookbook. So there are some differences when you're working with different command lines. So for instance, when you're working with Puppet and you're working with one version of Puppet and you want to do, what is the command to sign a requested certificate, The top example here is for Puppet version 2.7, whereas the lower option here is for Puppet version 3. And that's something to bear in mind when you're going through your interview process, is that the tools that are used within a continuous integration, continuous delivery DevOps model do vary. And so you want to be able to talk knowledgeably about the different versions of the tools so that when you're talking to your interviewer, you're able to show the deep knowledge that you have. Which open source or community tools do you use to make Puppet more powerful? And essentially this question is going to be asking you to look beyond the core foundation of Puppet itself. And so the three options you have is being able to track configurations with Jira, which you should be doing anyway, but it's a great way to be able to clearly communicate the work that's being done with Puppet. Version control can be extended with Git. And then the changes should be passed through Jenkins. So the three tools you want to be looking at: integration with Jira, Git, and Jenkins. So what are the resources in Puppet? Well, fundamentally, there are four. The resources are a basic unit of any configuration management tool. They are the features of the nodes. They are the written catalog and the execution of the catalog on a node. So as we dig deeper into Puppet, one of the things that you are likely to be asked regarding Puppet is, what is a class in Puppet? And so a class in Puppet is really the name blocks in your manifest that contain the various configurations. And this can include services, files, and packages. And we have on the screen here an example of what a class would look like when you write it out. And you may want to memorize just one class. Don't memorize just a whole set of classes. Just memorize one. The person that's interviewing you is just really looking for someone who has a working knowledge. They're not looking for you to have memorized complete massive classes, but having one small class to be able to illustrate the experience you have is extremely valuable to the interviewer, particularly if it's a technical interview. So as we move into Ansible, one of the things that you're going to be asked around Ansible is, what is Ansible role? So a role is an independent block of tasks and variable files and templates embedded inside of the playbook. So the example we have here on the screen actually shows you one role within a playbook. And in this role, it is to install Tomcat on a node. Again, as with previous question within Puppet of a class, it's probably good to have memorized just one or two roles so you can talk knowledgeably about Ansible when you're having your interview. So when you're working with Ansible, when should you be using the curly brackets? And so just as a frame of reference, there's often two different ways that these kind of brackets are referred to. They're either referred to as French brackets or curly brackets. Either way, what you'll be wanting to ask is, when would you use these specific types of brackets within Ansible? And really, the answer comes down to two things. One is that it makes it easier to distinguish strings and undefined variables. And the second is for putting together conditional statements when you are actually using variables. And the example we have here is this prints the value of, and we have foo, and we have to then put in the variable conditional statement of foo is defined as something. So what is the best way to make content reusable and redistributable with Ansible? And there's really essentially three. The first is to include a submodule or another file in your playbook. The second is to import an improvement of an include, which ensures that a file is added only once. And then the third is roles to manage the tasks within the playbook. So a question you will be asked is, provide a differences between Ansible and Puppets. So if we look at Ansible, it's a very easy agentless installation. It's based on Python. You can configure it with YAML, and there are no support for Windows. In contrast, Puppet is an agent-based installation. It's written in Ruby. The configuration files are written in DSL, and it has support on all popular operating systems. So if we dig deeper into the actual architecture, Ansible, it has a much more simple architecture, and it's definitely a push-only architecture. In contrast to Puppet, it's a more complicated but more sophisticated architecture where you're able to have a complete environment managed by the Puppet architecture.
So guys, we have come to the end of our full course. If you have any doubts or questions, ask them in the comment section below. Our team of experts will reply you as soon as possible. Thank you and keep learning with Simplilearn. Hi there, if you like this video, subscribe to Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, you can check the description box below.